Hi, let's talk about implicit differentiation. If I have a function such as 4x plus 2y equals 8, this is a function that has both x and y variables, and I might be asked to find the derivative of y with respect to x. Well, to do that, in this case, the easiest thing to do would be to solve it for y. So I'll move the 4x term to the other side by subtracting it from both sides. And then I would divide by the 2 every term, and I would get y equals negative 2x plus 4. Now if I want to take the derivative of y with respect to x, I see that the answer would be negative 2. And that's great when a function is easily solvable for y, but there are other functions that aren't so easy to solve for y. For example, let's say I have the function 4x squared minus 7xy plus 2y squared equals 48. You would not be able to solve this function for the variable y. So we need another method for finding the derivative of y with respect to x when we have a function in x and y, but we're not able to solve for y. So let me show you how we would do it for this first one. That's a lot easier. 4x plus 2y equals 8. And then we'll come back in a few minutes and we'll do 4x squared minus 7xy plus 2y squared equals 48. So I'm going to take the derivative with respect to x of each term. So the derivative with respect to x of each one of these terms. Okay? And if the variable in the expression is x, then taking the derivative is the typical way we do it. So the derivative with respect to x of 4x is 4. And I'll go over here to the right-hand side. The derivative with respect to x of 8 is 0. But when we get to a term that involves a y, we have to first take the derivative of the term, which would be a 2, and then we have to say, well, we don't know what the derivative of y with respect to x would be. Okay? So for y, it's basically the chain rule. We're going to take the regular derivative, and then we're going to take the derivative of y with respect to x, and we're just going to have to leave it as that expression. And so now I'm going to solve this for dy dx by subtracting a 4 from both sides. 2 dy dx is negative 4. And then divide both sides by 2. And I get dy dx is negative 2. Now that seems like a lot of work to get the same answer that we got before just by solving for y, but we're going to need that process when we have an equation such as this where it's impossible for us to solve for y.